Alright, should be a draft physics video presentation. The Piro. So unfortunately the Piro didn't really say this thing about I'm starting to sway him. But it is just kind of funny, so I'll read his most recent comment. That guy is the fake Piro. You have to click on the page or something, Gary. Yes, I did do that. That doesn't help. I mean, he has, obviously, I think he has actually broken into your account and is commenting on your channel as you, using your channel. Seems clear. Anyway, that was a whole thing I was trying to tell you when he showed up and there was two Piros, remember, with different icons. Yes, well, they don't have different icons anymore. And it links to your channel. And it's your channel, it's your videos and your playlists, and it's your channel. But anyway, that is not me. So why don't you fix that? You can only know this is me by checking. Checking how? By going to the channel. Yeah, so I did that. I don't, it's just kind of stupid. I don't know how he has the same name, the name the same, probably Unicode or something. No, he's using your channel. That's how he's doing it. So anyway, if we go to this fake Piro channel, it's Piro's channel. I mean, I could check to see if the videos, there's actually 1,000 videos. He couldn't have uploaded 1,000. So it's all of Piro's playlists are here. And then his videos are here. It doesn't tell you how many videos there are. But clearly the guy has uploaded a lot of videos if it's a fake account, right? Ah, well maybe it's true, because that's as far as he did. So he's uploaded all of your videos from 2 months ago to now. So it's a pretty well done fake account. At least he did the work. And he's hidden the number of videos, apparently. And yeah, so it's a fake account that has your playlists and your some of your videos. See, it would make sense for the YouTube to put the number of videos on here instead of not doing anything. So here's the giveaway. It joined June 12th, 2019. So that's where you can tell it's not Piro's channel. But you have to go through this much work. Now who's going to be bothered with that? So you really ought to complain or do something. So whatever. Because, yeah, I might as well just block you. Yeah, no, I'll block him. Alright. But yes, it is kind of disappointingly bullshit. Alright, so we will report. Well, I don't know if we can report him. It'd be more effective to block him, I think. Yeah, so I won't bother reporting. I'll just block. Alright, so anyway, I'll just delete Piro's channel because he's a jerk. Yeah, I'll delete his comment. Alright, anyway, so unfortunately there'll be no Piro anything video of any merit. Shucks. I mean, you ought to get a clue. I mean, you ought to just say, well, he is right, because, yeah, I'm realizing that all this wooey, wavy crap, there's really no evidence for any of it. Anyway, thanks for making these videos. I had no idea this channel was a thing, only because you mentioned on your main channel in the last video. Gonna watch them all before bed each night. Sweet. Yeah, why not? Like I said, I mean, it's pleasant enough, listening to my voice, sure. Anyway, pseudoscience is fun. Well, no, it really isn't. A thunderbolt probably destroyed Sodom and Gomorrah. Well, whether that ever existed is a whole nother story, just to reference a Bible catastrophe. Yes, but it is all just, let's find excuses for biblical bullshit, which is religion. So terrible. But you really shouldn't say this pseudoscience is fun, even when you're making fun of it. Because there's people who say, yeah, he's right, it is fun. Nostalgia is a disease. Pseudoscience is fun. Well, that doesn't even make any sense. So I wouldn't call this nostalgia. These are retroverts. I mean, these assholes who think when humans were uncivilized, things were really great, are just that, assholes. They're idiots. Women were just raped as property. They were bought and sold. The men killed each other all the time for almost nothing. They had fights over nothing. You know, war constantly. I mean, fuck you, you people who think the past was some idyllic wonderland where everybody just had a wonderful life, you know, shitting in pots. Fuck you. But anyways, stupid comment. I listened to TBP, the bad plagiarizers, to challenge the status quo. I don't know who TBP is. Now I listen to you to challenge TPBP. Great job. Yeah, well, whatever. Yes, everybody else is wrong. I'm right. So it makes sense to listen to me if you want to hear the right answers. So I have them. What are the orbs that are ejected from the sun? You're a retard. The sun's ejecting flames. There's no orbs ejected by the sun. It's just a stupid question. Alright, $10 in materials, and no one has reproduced this experiment to see if the ball speeds up again after leaving the loop. For circular, what was that? Oh, that's the Miles Massis bullshit video where pi equals 4. Yeah, well, it won't speed up after leaving the loop. It had to compromise its velocity to go around the curve, and the compromise in its velocity is a real compromise. I mean, it had to use velocity to curve, and unless you give it new velocity, like you have a car, a race car can get away with it, right? Because a race car can just step on the gas pedal, go around the curve, and come out faster than when it went in. But a ball is not a race car. So it lost velocity to friction, and it's not getting it back again. So that's a pretty simple one. 843, LOL. It's like I'm going back to 843 to find out the funny I said. Yes, there are periodic funnies, but we're not going back to find it. Alright, so there really hasn't been much going on. I was kind of hoping for the Puro video, and it never happened. Very depressing. Anyway, so this Tin Man guy, though, has been doing these Kirchhoff conundrum bullshit videos, you know, and this is the thing I went over before about how Professor Lewin was full of shit, that there's two different voltages in the same location, and blah, 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 blah. And it just has to do with the fact that you take an inductor, you have a circuit, a wire. You don't even need the resistors. You have a wire, and you stick a magnet in. You get different voltages in different locations, duh. Because in different locations there's a different amount of inductance in the wire. So this Tin Man guy has done a modification to it. Now this is his part 1 video, so he's got 3 others coming. So maybe he repairs his, I think, misunderstanding. So this is where he's going to measure the actual voltage of the piece of wire inside. So he has a donut coil, which means most of the magnetic field is inside the hyperboloid, whatever, inside the donut. And so the only piece of wire that's really getting radiated by the magnetic field is a little piece inside the donut, where if you put the magnet through the whole loop, all the wires getting irradiated, including your probe wires. That's why you get these erroneous readings, is because your probe wires are also in the circuit. Now the probe wires aren't in the circuit. But he says this weird, stupid thing. I'm like, These people just don't have a clue.
It's going to be the same as the top one.
It's not going to be anything like the top one. The top one's got the resistors that are stopping the voltage from being able to be nearly as effective. So the bottom one is where that's where the energy is being produced. That's where the voltage is being produced, not the top one.
These are two resistors that have not been cut where the wires have been soldered together each end to form our loop. Now the problem here is we simply cannot place our scope across.
So he says we cannot. Of course you can. You just did it. You just placed it across the piece of wire where all the voltage is being created. This is where the battery is. It's essentially a plus and a minus sign on either side of it. This is where all the voltage is being created. So what do you mean you can't do it? You just did it.
Our bottom loop like that.
The trick would be is if you move these probe wires, does the voltage change at all? And it won't change at all because there's no magnetic field outside of the coil. So the only part of the wire that's being charged is the one inside the donut.
Because now we are measuring the voltage in a second circuit.
There's no second circuit. It is the circuit. It's the part that's creating the energy. It's the voltage generator. It's right here. This little section of wire is generating the voltage that runs the whole thing. The second circuit.
That is, the second circuit is now the bottom loop, and through our scope, through our 10 meg ohm resistance.
No, bullshit. No, it isn't. It's clearly, this is a ground probe. This is the sensing probe. You're just going to measure the voltage difference across the inductor. The inductor is going to induce voltage in the hunk of wire that's going in the inductor, and you're going to be able to read that voltage just like you read a battery.
Whatever it's got impedance. And now we find that our voltage has gone off the scale.
Yes.
And we have 81 to 82 odd millivolts.
Right, and I think it came out, so the across the resistors was 75 millivolts on one side, and the other side had some lesser amount, so it probably would all add up to 82. So no surprise.
We cannot measure the bottom loop like that.
Yes, you can. That's exactly how you should measure it.
The electric field is now exciting this loop here.
There is no exciting this loop here. It's exciting one little piece of wire that's actually in the field. Outside of this coil is very little inducible energy. There's no inductance outside of this loop because of the fact of how it's been made. It's a ring with the loops going around and around. So there's very little that goes out. It all gets reflected on the inside. So there's lots of energy for something inside the loop and very little energy leaking outside the loop. So I don't even know why he's doing this, because it's so different than the Lewin experiment. It's not the same experiment, so I don't even know what he's trying to do here.
Which our scope is included in. The very same way it induces the EMF on our primary loop.
Yeah, well, it's not doing any of that. It's not inducing anything except in that one little piece of wire that's actually in the field that's active.
To measure the bottom, I know we don't really
He's going to do something retarded. I think he's going to put the probe inside the loop. You can't measure it. Your probe is now part of the experiment. You put the probe inside the donut, you've just ruined your ability to measure anything real.
Because it's going to be the same as the top. We have to
So
go
that's what he's
through
doing.
the loop with our measuring apparatus.
Well, that's just fucking retarded. So yes, way to fail. We'll put our measuring apparatus right into, it's like putting a thermometer on the flame instead of in the liquid you're trying to test or something. It's just, you're guaranteed to fail.
Which, that's not going to happen. Until now that I just get it.
Alright, anyway, enough of that. So I'll have to watch the other parts to see. Maybe he corrects his understanding of what he's attempting to find out. I mean, the only thing at controversy in the Professor Lewin challenge by the Kaboom guy, or whatever his name is whether or not probes are being affected. So whether he's poorly probing the experiment, that is, he's attempting to measure something, but the measurement is polluting the measurement, the process of measuring, because the measuring device is becoming exposed to the radiation it's attempting to measure. Radiation in one thing, and it's in radiation from another thing kind of idea. And so it can't accurately measure the voltages. So there are not two voltages in the same location, as Lewin is suggesting, because the probe wires are being affected differently, and therefore they're screwing up the measurement. All right, we've been there and done this. All right, so I don't know if there's anything else to, the rational science guy, which is the rope theory, Bill Gates, did make a couple of videos, kind of boring. So the one, he got a comment on gravity, and so he has this dopey theory. Excuse my French. So I should have loaded the other camera so I could draw this, but I should be able to explain it simply enough. Well, I'll pause the video. Yes, yes, I have the option to pause now, so let's use that. Oh, gotta do it this way. I'll be back. I should be back. Hopefully things didn't get screwed up. All right, so so the Bill Gates guy is attempting, he has this rope theory, which is just kind of nonsensical. Yeah, I have to, sorry about the shadow, I didn't think of that, so I should have had the overhead light on, but whatever. We'll just make do. And this gets to this whole thing of how we see things. So his theory is that every atom is connected to every other atom in the universe, which is just nutty. And so he kind of draws it by drawing lines like this. So gravity would somehow be going through what you could consider some focal point or a pupil of some kind, rather than, and so this way he can say that, well, as you get further apart, the gravity, you don't see it because these angles get infinitesimally small, and the differences in the angles, and but the whole thing is sort of a misidentification of how this atom would be connected to this atom, or this atom would be connected to this atom. It'd be more this atom connected to this atom. So instead of drawing the straight lines between two objects, he draws them as if there's a pupil. And like I said, the pupil is what fools us. Things look smaller in the distance, not because they got smaller in any way. They got smaller because the angles change, because we send everything through a pupil. So everything does this crossover thing. So as things move further apart, the effect, the optical effect, is for something to look much smaller at a distance, because of how these angles have to change, because you're not seeing it based on the direct view of light just passing between the two objects. So when two objects are gravitationally affecting each other, if you were to argue, okay, that each atom was connected to each atom, then there'd be a certain number of lines, and that's all there'd be. So there'd be like, whatever, 1 million or 1 billion lines between the two things connecting each atom to each atom. And no matter how far away you made them, there'd still be 1 billion lines connecting those two things. So you'd have no way to say, well, why at a distance does gravity get weaker? So you'd have a really poor explanation of that. And to some extent, if it wasn't for pupils, you can make similar arguments about how we see things in terms of the intensity. Because the real point is that each point is sending light in all kinds of radial directions. So I just keep making this point that everything is spewing, okay, radiation in all directions, and it is the separation between those lines, that is the divergence, that is the inverse square law. So, I mean, the simplest way to understand the inverse square law is to understand that if you're right here, if you're an object this big right here, you get hit by all 10 lines. But if you're an object of that same size here, you only get hit by 2 lines, 3 lines. And that's the real difference. So when something's close, it's going to feel more force because it's getting hit, quote unquote, by more of these lines than at a distance. And that's the same thing that happens to us visually. Because the light does the same thing as the inverse square law. All the rays are diverging with distance, and it's the divergence of the rays that completely imperfectly explains the inverse square law. That's why there's an inverse square law, is the divergence of the rays in both dimensions, in the 2 dimensions. And that explains why gravity decreases by that specific amount, by that law. And nothing else explains it as perfectly as understanding that everything is radiating rays in both dimensions that are diverging in both dimensions. They're getting further apart this way and getting further apart this way. That's the square of the inverse square law. All right. So I just wanted to say that, just because there's, we have this huge misperception. This gets into the whole lensing arguments and everything else, that somehow galaxies far away are little tiny things, but they're really not. They're still big, giant galaxies, and most of the light they're radiating, okay, is not this single angle of light that we decide to lens. That's not most of the light coming off of the galaxy. The galaxy is shooting a whole bunch of rays of light to all these locations, and the ones that are the most relevant are the ones that would be parallel to another galaxy. And so in effect, when it comes to gravity and some of these other things, you could sort of understand well, not when it comes to gravity, that's not the right way to say it. You can just understand that the distance just has to do with the fact that nothing radiates straight line. I mean, nothing parallel rays are a tiny percentage of the rays that are leaving the object. Most of the rays that leave the object are not parallel. They're diverging. Yeah. But it would be a whole, we'd see everything so much differently if we weren't seeing it based on the fact that all the light we see has to converge on our pupil. It's not the light that's here or the light that went here. We don't see the light that hit all these other places from the same exact location. So one location is shooting photons, at different moments in time, not at the same time, but at different moments it's shooting the photons. I'm not really illustrating it. 1 millisecond the photon from one location goes here, the next millisecond it goes here, goes here, goes here, goes. It's covering the entire, it's spreading it over 180 degrees in 2 dimensions, and that's the so this gets towards this infinite plane kind of argument when it came to charge and stuff. So if you could make such a thing as the infinite plane, or you could have 2 surfaces that were so big that you really don't even have to be that big, just 4 meters by 4 meters. If you put them close enough together, most of the interactions will be without any inverse square law. The force will stay the same no matter how far apart you move them, as long as you don't move them really far apart. So if you just move them from 1 inch to 2 inches, you'd have exactly the same amount of force or gravity if they're close enough. So when things get close enough, there's no inverse square law. So it's another argument for this radial theory, is that's exactly how light would work. So if I have two light bulbs that are big enough, you know, their surface that's emanating light is large enough, and I put them close to each other, 90% of the energy will not dissipate or change in any way. So it wouldn't matter whether they're 1 inch apart or 2 inches apart, the amount of light that you'll measure will be exactly the same. The amount of energy hitting one surface and hitting the other surface would be exactly the same. So there wouldn't be any inverse square law. And if you had infinite surfaces, or very, very huge, giant surfaces, it wouldn't matter how far apart you move them, it would always be just as bright. So you could never make the light bulb dimmer, theoretically, if the source of the light is as big as the receiver, and they're really big. You know. Anyway, so it's sort of a really important part of physics that I didn't really understand, this optics thing, in the sense that you know, it was just never talked about. I was never exposed to recognizing just how distorted our view of energy or the reality is, based on the fact that we are seeing things based on the fact that we go through a focal point somewhere in arbitrary space. I mean, our pupil is not very arbitrary. It's a certain distance from our retina, but it imposes a real filtering. It's a tiny percentage of the light that we're receiving through this tiny hole. A tiny percentage of the real images that are all over the place. We're just receiving one tiny image. You know, there's big images right here. There's a big image of everything on that going there that way. There's a huge one here. You know, I could pick it up with a big giant lens right here. The image is there. I don't need the lens for the image to be there. It's already there in space. So it's so much, you know, like I said, the world is so much different, the reality, than the distorted view that we're getting, in the sense that this room is full of much more light. I mean, an insane amount of light compared to the little bit that's going in my pupil. I see, wow, it's really bright in here, but it's really like 1 billion times brighter, because there's a ton of photons I'm not collecting in this little tiny pupil. Okay, something like that. That's probably enough. There's just nothing going on. I mean, it's just nothing interesting, and I should just make another overview video, I suppose, you know, hitting some of the other subjects. You know, again, I can solicit conversation if somebody wants to defend conventional physics in a live conversation, a recorded conversation, and think they're competent to do so. I would love the challenge. I'd love to be able to interrogate your physics. You know, and just point out, have you defend it's something other than incredibly weakly evidenced speculation. It's all you really have is just, and I'd say just insanely reckless speculation, where you've said you've proven something when you haven't even come close to the burden of proof. And I'd like you to explain how you have met that burden, that the crappy evidence you have is somehow not crap. You know, so if you could do that, if you can man up and accept the challenge of having your physics interrogated, I'd like to do some inquisitioning. So anyway, see, the Bill Gates talks to people, but the only people he'll talk to are people who are you know, have some willingness to go along with his bullshit. You know, but he's absolutely correct in the sense of claiming that conventional physics doesn't have a clue. I would say he's absolutely incorrect when he starts arguing about how experiments aren't the most important thing you could possibly have as experimental data. It's just silly not to understand that experiments are critically important. And also to recognize that although mathematics does not define and doesn't really help with understanding mechanically how something happens. It does have a function in terms of, as I pointed out, I mean, it's formulas. It's a formalization, okay, of what we do know. And that is useful, to have everything in just simple equations that just recognize, like Ohm's law, recognize what the effects are going to be. They don't explain why the effects happen. Formulas. Okay, they just tell you what a given set of causes will create as an effect. A given set of variable circumstances. So yes, they're not, formulas aren't very useful as detective tools. They're not magnifying glasses. You know, they're not DNA sequencers. So anyway, enough, I think. No point in, there's just no point, unfortunately. Yeah, it just really is. So these I haven't watched yet. Part 3, yeah, I haven't done yet. So I guess I will. So this is part 2. Alright, so he was wrong-headed in part 1, so we'll just jump to part 2 maybe. But anyway, till next time. And such. Probably that. You'll have to do. I don't know why I have to right-click this, but you do. Anyway, till next time.